Hey everyone, welcome back. Our current unit is focusing on systems of equations. All that really means is you have more than one equation with more than one variable. All right. Our focus is that we are going to be dealing with two equations with two variables. So we have both an x and a y. There are several different methods that you can use to solve these equations. But what do we do when we notice that the problem's possibly already been solved and we're trying to see whether or not this point is a solution? That's what we're going to focus on here today. The IXL assignment is AA1, which is XY a solution to the system of equations? And that shortcut code is N46. All right, let's get started. Our question is asking us if the point 1, 5 is a solution to this system of equations. Well, there's multiple different ways that you can solve this. If you happen to have a graph, you could graph these two equations and see if they intersect at the point 1, 5. I don't happen to have a graph handy. And unless you have graph paper or some sort of grid, so that way you know that everything's evenly spaced and it will be graphed correctly, it's better to do it algebraically, all right? That's what we're going to focus on here. And the algebraic method that we're going to use is substitution. And you should recognize that word because we did quite a bit of substituting in the past. And if not, once I start it, I think it'll come back to you. Because remember, substitution is like when you are subbing someone out in basketball, or you have a substitute teacher in class. One person is replacing another. Substitution in this case is when we are taking a number and we are replacing it with that variable. Before we can substitute, we need to identify what numbers are aligned with my assigned variables. This ordered pair right here, 1, 5, is what we're going to use because we want to know if that's a solution. All right, so with the 1 and the 5, which number is my x value and which is my y? If you don't remember, the nice thing is the title reminds you. It reminds you that in ordered pairs, the first number is your x value, and the second number is your y value. Which means for this problem, every time we see an x, it's going to be substituted. We're going to replace it with a 1. Every time we see a y, it's going to be substituted, replaced with a 5. All right, let's start with our very first equation here, and I'm going to rewrite it. We have y is equal to 3 times x plus 2. But I can use substitution, so that way I no longer have variables and I can solve it. We're going to substitute our 5 in for y, and then my equals 3 stays the same, but instead of 3 times x, it will be 3 times 1. Because 1 is our x value. So we're substituting 1 in for x. And then plus 2. All right, now I have no more variables, which means I just need to simplify this using order of operations so I can determine whether or not it makes a true statement. Okay? So nothing needs to be done with the 5. I just need to simplify this side here and see if I end up getting the answer of 5. Well, order of operations says multiplication comes before addition. 3 times 1 is 3. Bring down the plus 2. And I receive a 5. Is that what I was supposed to get? Yeah, it is. I was hoping to get a 5, which means this point is a solution to that line. How that would look is if I were to graph it, this point would fall somewhere on the line. All right, but I'm not done yet. I can't hurry up and click yes because I'm dealing with a system of equations. which means it has to be a solution. It has to work for both of them. I know that it checks out for the first one, but we're going to do the same thing. We're going to substitute. We're just going to use this second equation here and see if it also is a solution. All right, our second equation is y is equal to, oops, wrong color, x plus 4. And that's right here, guys. That's the second equation. All right, but I'm using the same ordered pair, so I'm going to substitute 5 in again for y and 1 for x. All right, this time there's no multiplication, which makes it a little bit easier. 1 plus 4 is 5, and that's what I was supposed to get. 5 equals 5. All right, it works for both of them, which means if both of these lines are sharing this point, when I graph these lines, that is the point, 1, 5, where they will intercept. That is the solution to the equation. So I can click yes. Bravo. All right, let's try another one here. Is 2, 3 a solution to the system of equations? Right, in this case, our equations look different because they're now in standard form. But even though my equation's in a different form, I still have an x and a y. So my process is no different. I'm going to substitute my values in and solve it to see if it works and falls on that line. All right, let's label our x and our y again because I don't want to mix them up. That would be really bad. All right, in an ordered pair, the first number is our x and the second is our y. So we're going to substitute 2 in for x and 3 for y. Let's do this with our first equation. So 2x plus 5y equals 19. All right, when we substitute, instead of 2 times x, it will be 2 times 2. Instead of 5 times y, it becomes 5 times 3. And I want to see if that equals 19. Let's follow order of operations to simplify. Multiplication comes first. The nice thing is I can do both sets of multiplication simultaneously. 2 times 2 is 4. 5 times 3 is 15. Let's add them on up. 4 plus 15 is 19. Bingo, that's what I was supposed to get. But remember, you can't just hit yes because I need to verify that it also works for the second equation. All right, I think I'm going to come over to this side because I don't want to run out of room. 4x plus y equals 3. All right, now that I've written my equation down so I can organize my work, let's go ahead and substitute. Instead of 4 times x, my x value is 2. It will be 4 times 2. And then instead of plus y, it is plus 3 because my y value is 3. All right, order of operations, multiplication comes first. 4 times 2 is 8. We have 8 plus 3 equals 3. Now it's possible that you could look at this and say, ooh, this is not going to be right. I don't even really have to add these numbers together. If that's the case, cool beans, answer it. But if you want to just triple check, because sometimes when negatives are involved, which in this case there aren't, but if there were negative involved, that can change things. 8 plus 3 though is 11. Does 11 equal 3? No, it does not. which means this point is not a solution. It falls on one of the lines, but since it's not shared by both lines, that's not their point of intersection. That's not their solution, which means I have to select no because it does not work for both. So it's not a solution to the system. Excellent. All right, let's jump up a level here, guys, and we'll do one, maybe two more together. We'll see. Oh, that's not what I wanted. Here we go. Let's see. Okay, we'll just jump up a level because we've already done one like that. So let's do one in the challenge zone. So you guys may or may not get to any of these because remember your goal is to get a SMART score of a 60. But if you happen to get to one that has fractions and negatives, this is still a good example because maybe you'll come across a problem that doesn't have fractions, but it does have the negatives involved. This will still be a good one. All right, let's label our points so that way I make sure that I substitute the right values in. The first number, the positive 5 is our x. The second number, the negative 5 is our y. My first equation here is y is equal to negative 1/5 x minus 4. All right, I know we have a fraction, but don't worry. All right, you guys can do it. The nice thing is multiplying fractions is the easiest operation with fractions. It's my favorite, so don't be afraid. All right, substitution time. My y value is a negative 5, so I'm going to substitute. I'm going to replace the letter y with the number 5, or negative 5, my bad. Negative 5 is equal to the fraction negative 1/5 times x. That would be negative 1/5 times 5 minus 4. That does not look like a 4, does it? There we go. All right, multiplication comes first. I'm actually going to come off to the side here to show the multiplication of my fraction. All right, we have negative 1/5 times 5. If you recall from elementary school, when multiplying fractions, both numbers need to be a fraction. So think back, we reviewed this when we talked about slope. How can we turn any integer into a fraction? Put it over 1, because fractions are division, and if you divide something by 1, it doesn't change its value. So you can rewrite any integer as a fraction by putting it over 1. Now when you multiply, you just multiply straight across. So you multiply your numerators together and then your denominators. Negative 1 times 5 would be a negative 5. 5 times 1 would be a positive 5. If you can simplify your fraction, you want to simplify it. And remember, fractions are thought of as division, so always see if you can divide and get an integer first, and then if not, simplify your fraction to lowest terms. In this case, we get lucky because negative 5 is evenly divisible by positive 5, negative 1. All right, let's come back up here and write this. Therefore, we have negative 5 is equal to negative 1 minus 4. Negative 1 minus 4. Think about a number line. I start at negative 1 and I subtract 4. That means I'm going backwards, so it'll continue into the negative, which would be negative 5. And that is exactly what we wanted to get. So it does work for this very first problem. All right, uno más. We got to plug it into the last equation there. I'll come over here again so there's more space and it's separated. Y equals 3x, oops, wrong color, plus 10. All right, let's substitute our values in. Our y value is negative 5. And our x value is positive 5. So instead of 3 times x, we have 3 times 5 and plus 10. All right, multiplication, 3 times 5 is 15. 15 plus 10 is 25. Does that equal a negative 5? No, it does not. So once again, we have another problem where it works for one, but not for both. Therefore, it's a solution to the first equation, but since it's not a solution to both, it is not a solution, it is not an answer to the system. Therefore, I have to select no. It's yes. What did I do wrong? Let's clear this and see. Actually, I don't want to clear it because I want to be able to correct my mistake. Oh my goodness, I see exactly what I did wrong. All right, let's clear this and look. Wait. I copied the problem down wrong. That's what I did. Okay. Right here, it's a negative 3, but what did I write down? A positive 3, which means my signs were wrong and I got the wrong answer. I promise I did not mean to do that, but that right there is why I tell you guys when it comes to long problems like this, not to do it all in your head, because I even made a copying error. I should have known to look back and verify that I copied the problem down correctly, because one negative changes the whole thing. All right, let's go ahead and correct my work here. There should have been, this should have been a negative 3, which means when we multiply negative 3 by 5, it's a negative 15. Therefore, negative 15 plus 10 is in fact a negative 5, and it does work for both. All right, but here's the nice thing, guys, and I really hope you personally look at this, because after you miss a problem, it explains what you did wrong, which is why if you do your work on a small personal whiteboard, or if you do your work on paper, you can compare your answers just like I did and find your mistake to see whether it was a simple mistake that was silly like mine, or whether it was a mistake because you didn't understand it at all. All right, so there we go. Extra bonus lesson in with this video. All right, I hope that you guys have a wonderful rest of your day. And as always, if you need anything, just send me an email. Bye, guys.